So let's see what happens if we increase the resistance to 1000 ohms. So I put a 1000 ohm resistor here and I plug in my power source. And finally I connect the probes to once again measure the voltage drop across the resistor. So let's sweep through the frequencies again. So starting at 100 hertz, the red curve is the output again, and so we're keeping an eye on the amplitude of this red curve. So let's start increasing the frequency, and note that the amplitude of the red curve is increasing. And now it looks very close to the input signal. Note that it's at 1.2 kilohertz again. So the maximum gain happens at about the same driving frequency. As I increase it even further, it seems that the signal is decreasing. Look, but it's taking much longer to see a significant difference between the input and output. So now let's turn off the input signal, the pink curve, and just look at the red curve. And now we'll go backwards. We'll start at the high frequencies and slowly go back to the smaller frequencies. Note that the peak increases again as we reach our maximum amplitude, and now it decreases again. Now, what would happen if we change the capacitor to a capacitor that is 10 times smaller? Would the resonant frequency be the same? Would the peaks look similar? Let's explore that. We're still measuring the voltage drop across the resistor, but now we have a capacitor that is 10 times smaller. And we'll switch back to the 510 ohm resistor. We'll once again do a frequency sweep and see how the red curve, the output of our system, changes. At low frequency, we see again that the red curve has very small amplitude. And as we increase the driving frequency, the amplitude of the red curve increases. But now, the maximum amplitude is reached at about 3.6 kilohertz. As we further increase the driving frequency, the amplitude of the red output goes once again down to 0.